The challenge posed by quality in Factorio is both alluring and devious. Who doesn't want faster assembly machines, more efficient solar panels, or asteroid collectors with more arms? But in order to get them, we need to deal with a real dastardly problem. What happens to all the things that aren't of sufficient quality? Simple question, devious answer. We start at the beginning. 1. The principle. In a conventional Factorio environment, i.e. no quality, if we want to make a thing, say a gear, we simply feed an assembly machine or a bank of assembly machines with iron plate and it will give us that thing. When we add quality modules to the assembly machines, a certain number of these things will increase in quality. There are 5 different qualities the thing could be. The first is normal quality, or 1 dot. Now, me personally, I'm never going to remember the individual quality grade names, so I refer to each quality by the number of dots. I am but a simple chap. Normal quality items are the items we are already familiar with, the quality of item we have been dealing with in Factorio since forever. After normal quality, we have uncommon, or 2 dot, then rare, 3 dot, epic, 4 dot, and finally legendary, 5 dot. When we place quality modules in a process such as that on the screen, 1 dot normal iron gear wheels, most of the output is always going to be 1 dot normal. Even with max quality modules in the assembly machines, only 25% is going to be upgraded in quality in some way. We are dealing with crumbs. The higher the quality item that is outputted, the less likely it is going to happen. Across one process such as this one, we can only expect about 0.025% to be legendary. To get 1 legendary gear, we would need to make 4,000 other quality gears, with maximum quality modules. As I said, devious. Each quality of gear wheel is a distinctly different thing in its own right. If we want to take the quality gear wheels and turn them into quality inserters, then we would need to match the quality of all the inputs with that of the finished inserter. If we want a 2 dot inserter, then we would need 2 dot gear wheels, 2 dot iron plates, and 2 dot green circuit boards. They all need to match. We could place quality modules in the assembly machines making the inserters. That would start the quality upcycle process and give ourselves the potential for making higher quality versions. But the core ingredients will always need to match each other and the recipe. There are no quality liquids. All liquids are the same quality. If a recipe requires a liquid as an input or outputs a liquid as an output, then those will be common for all the quality recipes. Molten iron is molten iron regardless of whether we make it with 1 dot or 5 dot calcite. The fact that it was made with legendary calcite makes no difference to the produced liquid. 2. The spectrum. Space age hasn't really been around for long, but the established convention for dealing with quality, if my YouTube feed is anything to go by, is to gamble. And by that I mean, I think, build a 1 dot factory, put as much quality in it as possible, and scrap everything that isn't 5 dot legendary. It's probably a lot more sophisticated than this. In fact, I'm almost certain it's a lot more sophisticated than I'm describing here. I haven't tried gambling. I don't precisely know the detail of achieving it. If this is what you are interested in, then I suggest you find a different YouTuber because, mathematically speaking at least, in my opinion, please don't hate me, in the range of possible different ways we can deal with quality, gambling, pretty please don't hate me, exists at the bottom end of a spectrum, and that spectrum is one of yield. Quality can only go up, it can't go down. For every process in a recipe chain that we run quality through, we roll an imaginary dice and we get to keep the good stuff each time we roll. We compound our probabilities. The longer the product chain we are dealing with, the more compound probability we get along the way, the better chances we have at the end of achieving the desired quality. Gambling, as far as my understanding goes, primarily deals with 1 dot ingredients. None of the recipe chains that lead to the gambling process have had the opportunity to increase in quality. We have not rolled the dice. We are relying on the probability of a single process. no compound probability has been utilized. This is what puts gambling at the bottom of the yield spectrum. The system that I believe to exist on the opposite end of the yield spectrum to gambling is what I am going to refer to as the full Monty. We are going to deal with each and every quality of ingredient for each and every process, for each and every recipe chain, with accommodation for all the various throughputs, sorting, scrapping, when to sort, when to scrap, for the entire factory. That is the full Monty. 5 parallel factories running in tandem, linked together to achieve the absolute maximum compound quality that is possible. If we want the full quality, then we need the full Monty. 3. Yield. This is a new term for Factorio. We haven't really had to deal with yield in vanilla Factorio before. We build a factory. It has a certain number of machines and produces a certain output. Pretty much no matter how we configure that factory, provided we use the same number of machines, we should be able to achieve the same output, give or take a couple percent. The idea of yield is that if we arrange that factory differently, if we take the same number of machines but just design a better factory, we can achieve a higher output. In a very real way, the old Factorio was almost entirely deterministic. We mine more ore, process more material, and we get more things. But that isn't the case here. There is a very real benefit to the yield of our factory if we design it well. We don't necessarily need to mine more material to get more things if we are processing that material more efficiently to achieve a higher yield. I mean, let's boil it down. Do we want more legendary things or less legendary things? It is more work, I'm not going to lie. That is the trade-off. But we don't play Factorio for fun. Do we? So we are here to work, aren't we? 4. Sorting. There are 2 absolutely fundamental mechanisms we will need to build in our full Monty factory many times. Sorting and scrapping. Each is devious in its own right. We start with sorting. We have a process filled with quality, and it outputs a variety of different quality things. Sushi, essentially. And one way or another, we need to filter off the different qualities so that the ingredients can get to the right processes. Okay, a word on sushi before we get started here, because it's pretty important. I don't like sushi. It's difficult to calculate, it's difficult to filter, it's difficult to control. My objective when dealing with this sushi of quality has been to immediately sort it as quickly as possible, as close to the source processes as I can get it. But it isn't just that. We must not scrap sushi. When we scrap sushi, we scrap everything, indiscriminately. We throw the baby out with the bathwater. If we scrap sushi, we are basically accepting that we are scrapping legendary. That's the reality. So one way or another, we need to sort sushi, not just because we need to match ingredients together along the recipe chain, but also because we can't scrap it. And if we can't scrap it, then it will jam. Alright, another side tangent while we are here. Conveyor belts jamming. This is now mostly a bad thing in a quality full Monty factory. Where before we might have looked at a finely arranged bus chocked full of conveyor belts with expensive stuff on them, jammed tight, ready to pounce into action, now conveyor belts jamming is mostly a sign that something is broken. Everything must be moving. If a thing gets to a process and it isn't needed, then there needs to be an immediate way to divert that stuff to be scrapped or somewhere else in the factory to be used to relieve the pressure, because a single quality item jamming and backing up will block all other qualities of the same item. To all intents and purposes, although this isn't how we are going to build the systems in the factory, legendary is the goal here, and anything that isn't legendary is technically scrap. So if some other quality backs up and we stop rolling the probability dice, then we stop potentially making legendary at 1 in 4,000. We gotta be in it to win it. If the factory ain't moving, then we ain't in it. So everything needs to be perpetual. If something starts backing up, this is now a problem. We might even have to start scrapping legendary things to prevent backups in other related items. If I'm not scrapping legendary copper plate, then I'm not making legendary green or red circuit boards or low density structure or gun turrets or basically anything that contains copper plate. We are stepping into much more complicated topics here that I will be covering later, but the point is, stationary conveyor belts, now not good. Back to sorting. We have a sushi belt of quality things and we need to sort them. Option 1, widgets. Here is a selection of widgets I've been collecting along my quality journey. None of them are quite perfect. I'm still working on the precise mechanisms of how to achieve this in the best way, but every time I try and reinvent the wheel, I copy it, so I've built up quite a collection. The most used one is probably this one, mainly because it is small and fits into tight spots, but equally, if throughput is the goal here, then this is limited to just 2 input belts. If we have more than 2 belts of sushi that we need to sort, then we either need to use one of the big daddy widgets or join 2 of the smaller ones together. One thing you might notice is that none of these widgets include any allowance for 1.normal ingredients. These are widgets for sorting crumbs. 1.normal ingredients are not crumbs. They are the bulk. 1.normal is the stuff we have to process in order to get to the good stuff. If we pumped 1.normal ingredients into these widgets, then the outputs will be utterly dominated by them. We need to deal with 1. Ingredients in the same way we used to deal with 1. Ingredients. As max flow as possible on their own dedicated conveyor belt bus, almost entirely separate from all the other qualities, and we then need to sort the quality off those belts and send it to the sorting widgets. I guess we are sorting twice. Once to separate all quality from the 1. And then a second time to actually sort those individually. The second option is to sort the sushi on site at the final processes. Basically keep the sushi belt running through the factory and sort it each time it runs through a process that needs that specific ingredient. It goes like this. We start with a sushi belt and we have a series of splitters that each removes a single quality from the sushi and sends it to the part of the factory that needs that quality thing. At some point, one of these ingredients is going to back up, and that will prevent any further sushi from being sorted. Okay. This isn't technically 100% true. If we are dealing with a process that is single input, single output, then as long as the factory is big enough, it should always be able to process what we throw at it. But when we have more than one input, then we always need a corresponding amount of the other ingredients at the same rate, and this will never happen. At some point, we'll have too much of one quality of one of the ingredients and too much of a different quality of the other ingredients. There will be an imbalance. So we need to be able to remove the specific quality from the system the moment it starts to back up. What we want to do is essentially fill the available conveyor belt that we've built with material, fill the machines with whatever they can hold, and then remove everything else. When we do this for all the qualities, we end up with systems like these. If we want to run sushi through our factory, then at each and every location that needs that sushi ingredient, we will need to build one of these systems, or something which achieves the same function. We will need to run this conveyor belt through all the processes that need it, and then at the end scrap everything that is left. It's not my preferred system, but it is a system. 5. Scrapping. The scrapping and the sorting are inevitably and inextricably linked. We can't scrap sushi, as I said earlier, so wherever there is sorting taking place, we need to be thinking about scrapping. The principle of scrapping is pretty straightforward. Some items scrap into themselves, some items take a long time to scrap. We need to be cognizant of both of these things. When an item scraps into itself, we can run the outputs of that scrapping process straight back into itself. FYI, I only do this if the scrapping outputs a quality that is the same that went in. If an item upcycles, then that item gets separated off and sent to the sorting widgets of the main factory. If an item scraps into itself, it doesn't necessarily need to re-enter the bulk of the rest of the factory. When an item scraps into other items, then those other items, if we are trying to make the absolute most of the quality compound probabilities, they need to be routed back to the sorting processes of those ingredients. If we scrap a red circuit board, then the green circuit board that comes out needs to find its way to the green sorting board sorting process. Same goes for the copper cables and the plastic. This is problem number 1. When an item takes a long time to scrap, then what we want to do, if we can, is turn that item into something else with a shorter scrap time and then scrap that item instead. Iron and steel we can turn into boxes and then scrap the boxes. Concrete and refined concrete we can turn into hazard concrete. This is problem 2. Copper is the perennial issue here. It makes sense to turn copper into copper cable and then to scrap the cable, but this can be painful just because of the sheer amount of copper cables that need to be scrapped. In sheer area of factory terms, it might be worthwhile just directly scrapping the copper plate rather than trying to turn it into cables and then just eat the long scrappage time. One thing I would caution against though, if you are scrapping copper plate, then just accept that copper plate as gone. If you turn that copper plate into copper cable with quality and then try to extract the upcycled copper cables before scrapping, thereby turning the scrapping process into one that is partially productive, just be prepared for a lot more copper cables than you need. My base on Fulgora, which includes quality, not the full Monty but close enough, has gone wrong dozens of times, and every time it is because of copper or copper cable. The upcycling, sorting, scrapping, sorting process of copper and copper plate is a loop that, when left unchecked, will eventually fill up a high quality line with more stuff than the factory can deal with, or at least that's what it does on my Fulgora base. This is precisely why I am scrapping legendary copper plate, by the way, and I am scrapping a lot. Just be aware, copper and copper cables with quality be the most devious. This whole conversation leads to the next inevitable point, which is how to deal with the results of the scrapping. A red circuit board gives us a green circuit board, plastic and cable, and this is just the scrappage of one item. So how do we deal with all of that combined chaos? Let's go through an example. This is my base on Vulcanus. It follows a pretty simple design philosophy. Everything over here is core production: iron, steel, copper, circuit boards, tungsten, you name it, it's here. Shopping mall is down here, and a big bus to route all the material from one to the other. If we think about green circuit boards in isolation, they are produced here and here, sorted in these two areas, and then scrapped in these two blocks. But we also produce green circuit boards when we scrap red circuit boards and blue circuit boards. We are also using a lot of green circuit boards and therefore scrapping a lot of things that contain a lot of green circuit boards that aren't legendary things down here in the mall. All of these areas need to be linked together. If a green circuit board is thrown out of any of these processes, and I would say green circuit boards are the second most abundant thing in this base, behind copper cables, then they all need to find their way into the same sorting and scrapping system. The way I have done it is with two bidirectional loops which are purely for scrap sushi, which run around the perimeter of the bus and deposit all the items from this scrappage wherever they need to go. 2 green belts of perfectly stacked sushi is 480 items a second, and that has turned out to be about the limit of what this base needs. And it's a big base. If you were building a smaller one, it's probably more than enough. Just one thing to note about this system though, copper cables aren't really included. I have a separate system just for copper cables which is entirely independent of these two loops. If I put a copper cable on the loop, it will find its way to the right home, but it isn't intended for high volume. Whilst we are here looking at this base, it will be pertinent to talk about the positioning of the scrapping. If we are using widgets for sorting, like here in this base, as close to the production of the items in question, then it makes sense to position the scrapping as close to that production as possible. Once a conveyor belt is given the option of scrapping if it overflows, every part of that conveyor belt after that option is now free bonus buffer storage. Balancing different materials for the final processes in these chains, generally a mall, is devious, as I've already said. The more stuff we can natively store in the base, the better. I'm not exactly the world's biggest fan of buffer storage, but if there is an item you care about, with quality, there is call to use a buffer if you feel the need. Truthfully, this base is massive. I have plenty of native buffer storage, so it hasn't really mattered to me. But if I had a problem, I may very well have had cause to build some proper buffering, which I haven't done in a very, very long time. And FYI, once a conveyor belt is given the option of scrapping, everything after that option, we want the belts to jam. And everything before that option, we want to be perpetual. The splitter, it's generally going to be a splitter, that creates this diversion option to scrapping is now the boundary between the old and the new systems. Jammed belts on one side, perpetual motion the other. The point is, the further away that the scrappage is from the sorting, the less natural buffer we get, and the less natural balancing we get to the materials at the final recipe in the chain. If we are choosing the second option for sorting, which was to run sushi through the base and then to sort it on site at the end process with one of these setups, the ones I showed earlier, then the scrappage would probably be best positioned to be basically the opposite. It would probably be best to put it as close to the final process as possible, probably as far away from the original production process as possible. Here maybe, if this was the system I was building. The outputs would still need to find a way back to the beginning though. That would be a new issue, particularly for copper cables. 6. Copper cables. If we are doing full Monty quality, then direct insertion for pretty much everything is out of the question. Fact, no way around it. Hello, post-production Bigfoot. I've always got to make some kind of mistake or critical, it's not necessarily a critical error, some of them are critical errors. This isn't necessarily as critical. So I've been speaking to someone behind the scenes about this script because, you know, the maths of quality and the fundamentals of quality are actually quite difficult. I wanted to run the script past him. This is someone who is familiar with both of those things, familiar with both the mechanics of doing quality. He's tried in many different ways and he's done it slightly different ways than I've done it. And the mathematics. And that's really kind of... Anyway, I've been discussing the script with him and he picked out, almost straight away to be honest, this particular comment about direct insertion. And he sent me this image. Now, there's a lot going on here. Let's just zoom into a small part of the factory. Now, what this is direct insertion with quality. It's pretty clever, to be honest. So we've got these two inserters, which are taking the 3-dot copper cables out of the 3-dot copper cable, the EM plant making those 3-dot copper cables, and directly inserting them into the EM plants making the 3-dot red circuit boards. We also have these two green bulk inserters, which are removing the quality cables that this thing happens to produce, which aren't 3-dot. So anything greater than equal to 4-dot gets ejected via this vertical green conveyor belt. We then also, this is actually my main thing about the recycling of the copper cables. We are also got these inserters, these stack inserters down here, which pick up the 3-dot cables, which we make elsewhere in the factory. Which it solves all of the problems that I could think of. You know, when he showed me this, I actually had to take my hat off to him because this is, not only has he proved me wrong, but he's done so in a really sexy manner. And I thought this was just really, really clever. I thought it was really good. I mean, I did go away and have a little think, and the ultimate flaw is, it's not really a flaw, is what happens once we've upgraded all these EM plants with the maximum quality modules, because in that scenario, these two stack inserters are only picking up 2/3 of what you would have expected them to, because 1/3 of the material being made in the EM plant with the copper cable is going to be of a greater quality. So we are both losing a certain amount of productivity from the EM plants making the red circuit boards, because some of the some of the copper cables we were expecting aren't going to be of the right quality. But we're also putting that all onto this ejection system. We're going to have more copper cables which upgrade in quality and need to be floated around this system and fed back into the parts of the factory which are dealing with these higher tier, higher quality cables. And this is probably something I didn't really mention in the video, because, you know, this is something that we need to worry about. At the moment, we've only got these 2-dot tier 3 quality modules in these EM plants, which is in general terms, it's quite a high tier quality module in real terms, but in actuality, in comparison to the Ultimate, it's not very good. Once we need to be able to design these factories not just for the high quality tier modules that we can get right at the end, but also at the beginning. And sometimes those two scenarios place different burdens on our factory. We might design it for a low throughput sort of system. That's the way I would see it with these modules. And then once we upgrade the modules, we start to experience problems with the system that we've built. Alternatively, we might have other problems that are dealt with because we've got too much of something else, or something, or not enough of something. This whole spectrum of like changing modules, upgrading the modules, how the factory deals with that along the way. This is all part of the chaos that I'm trying to get to the bottom of. Anyway, that's the end of me. Let's get back to the video. In every step along the chain, we need to be extracting quality, and that includes copper cables. And copper cables are like rats. There's always more than you think there are. Hidden, lurking where you can't see them. I have a copper plate to copper cable loop on Fulgora, the exact kind of system I warned you against doing earlier. There's a lot going on here in Fulgora, but just understand I am processing a lot of scrap here on this base, and all of it is being routed to a single enormous sorting widget which sorts everything onto its respective conveyor belt. 17 different items of 4 different qualities from potentially 24 belts of unsorted stacked sushi. That is potentially 5,760 items a second. This widget can't handle that number though. It's been stress tested, but it can't reach that. That's a big number. I digress. The loop is as follows. Copper plate overflows. It gets turned into a copper cable. It gets routed from wherever in the factory to this sorting widget where if it overflows, it gets turned back into a copper plate, which gets diverted to this sorting widget where if it overflows, it gets turned into a copper cable. Round and round and round in circles it goes. Before I built this base, I calculated the approximate amount of copper cables I was going to be producing. I have a spreadsheet. I will make it available when it works. I've got a Fulgora video coming. This spreadsheet only calculates the primary copper cables that we get as a result of processing the mined scrap. It does not calculate any of the copper cables that result from this infinite loop. After much playing with this base on Fulgora, I believe the actual number of copper cables to be at least double what I calculated. It is the number one cause of this factory failing. Copper cables and copper plates running round in circles. Copper cables are the devil. God damn the copper cables. I warned you against doing this exact system because if I was doing this base again, I would calculate how many cables I thought I was going to produce and then I would times it by 4. Green circuit boards, by the way, I would do the same but times it by 2. If you're going to do it, just be aware of what you're getting into. This copper cable issue is a little more straightforward for my base on Fulgora. We have this one big widget, everything gets routed here. On Vulcanus, it's a bit different because we aren't getting all of our material from processing a single item, the scrap. We get them by processing many materials. Those sites of processing are inevitably going to be more spread out. So looking a bit closer at the part of the base that is relevant here, let's just go through the fundamentals. Firstly, all of the copper cables that we need to worry about come from circuit boards. We might get a few from power poles and substations and such if we are pursuing those items with quality, but in terms of volume this is going to be peanuts. If we are building an entirely separate system just for copper cables, then it only really needs to cover the green and red circuit boards. Second, the cables we need to worry about come from 2 areas. They come from scrapping any green and red circuit boards that overflow from the perpetual system, and they come from the processes directly feeding those circuit boards in the first place. We need to collect all of these cables, send them to a set of widgets to sort them into their respective qualities. We need to give all of those individual qualities the option of being scrapped if they overflow, and they then need to be sent to all the individual circuit board processes back to the beginning essentially, and they need to take precedence over the cables that are being produced locally. This is a chunky logistical system, I'm not going to lie. It is solely born of me not knowing what I was doing with quality. I built a factory and then I made it work. come hell or high water. But it is very indicative of the copper cable issue. It is not something to be underestimated. 7. The maths. We need 5 factories running in parallel. That's a lot of factory, and they're not all going to be the same factory neither. Each quality is going to make unique demands on the factory, and we need to accommodate those demands within the factory design. There's no point building the same number of assembly machines for all 5 qualities. If we build 100 machines for 1 dot, we don't want 100 machines for 5 dot. We probably barely need 1 machine for legendary if we only have 100 machines for common. And the rest of the qualities in between will need numbers varying in between those two extremes. How do we calculate this? There is no perfect. Let's not beat around the bush. The number of machines we need for each quality tier is going to vary depending on the level of quality of modules being used, the speed of the machines being used, the amount of stuff doing the infinite loop dance. There are a lot of variables. The maths won't tell you what to build here. If we take a single machine and a single process, say an EM plant making a copper cable, and we fill it with the max quality that is possible, then we can expect about a third of the copper cables being produced will be a higher quality than what was expected. But we are also going to be receiving copper plate of higher qualities that have been through the dice rolling process already and come to the same result. If we are making copper plate from molten copper, then we can expect about a quarter of the copper plate we produce to be a quality other than common. It's different because we only get 4 modules in a foundry, whereas we can get 5 in an EM plant. So if we were trying to calculate how many 2-dot copper cables we were expecting to produce, we would need to take the amount of quality cables we get as an excess from the 1-dot copper cable process in the EM plant and add it to the amount of quality cables we get from processing higher quality copper plates from the foundry, the third plus the quarter of their respective outputs. It wouldn't necessarily equate to 7/12. And this is just copper cables, my personal nemesis. The further down the recipe chains we go, the more quality we can expect, and the more difficult, nay, even impossible, it becomes to calculate. This is what we want, by the way. This is why we are building the full Monty in the first place. The probabilities compound the further we go and the more quality stuff we can expect as a result. These are all good problems to have. It's just completely impossible to predict. I would go so far as to say that, mathematically speaking, it is potentially chaos and therefore uncalculatable other than to draw non-specific conclusions, but I can't be sure. The best method that I can come up with is to build the number of machines that I think I need for 1 dot and then build a set proportion of machines smaller for each successive quality. Build 100 machines for 1 dot, build half that number, 50 machines for 2 dot, build half that number again, 25 for 3 dot, 12 for 4 dot, 6 for 5 dot, if I was using a 50% reduction each time. But, I've been known to use different numbers here. I've used 3/4 reduction. I've used a 1/3 reduction. The truth is, I'm still playing around with this, and largely because the maths is so damn devious, I can't be sure which parts of the factory need to be bigger or smaller. It's very difficult to tell which areas aren't producing enough throughput in a quality factory, because the infinite loop keeps delivering complete chaos from all the things being scrapped. So I calculate the 1 dot factory I want to build, and then for every process I first build the number of machines that the analysis tells me I need for that 1 dot factory, and then I use a fixed reduction of machines for each successive tier of quality. The processes early in the chain, where probabilities haven't accumulated, I use a 75% reduction for each tier of quality, and as I work through the recipe chains, getting deeper and deeper into the accumulated probabilities, I use a smaller and smaller tier reduction right down to a third, 33%. 33%, a third, is what I consider to be the limit, that when all is said and done, when we are so deep down into the dice rolling that the limit of the probability has been reached at the ends of all the recipe chains, the absolute maximum I consider to be possible is that for each successive tier of quality, we can expect 2/3 of what we calculated for the previous tier, all starting from the 1 dot factory we designed at the beginning. This is the happy place I have come to reside in. It makes logical sense to me. I can calculate things on the fly. I don't have to analyse each and every damn copper cable. It's not perfect, but short of analysing every damn copper cable, nothing is ever going to be perfect. And the thing is, with the way we are building this factory, with every material and item given the opportunity to be scrapped, the factory is going to self-balance whether we like it or not. If we make a mistake with the number of machines for any one process, such that the ingredients start backing up, they are going to be instantly scrapped and the jam is going to be cleared, whether we like it or not. Fundamentally, the more throughput we build, the more opportunity we give the material we produce in the factory to work all the way through the recipe chain so that it can get the best opportunity to increase in quality, and if that throughput is non-optimal in some area, then the material is scrapped and upcycled in a manner that is slightly less productive. That gives us slightly less yield. We just move down the yield spectrum a little bit. We can only do the best that we can do. 8. Block design. The simplest method that I have found for actually laying out a block in a quality factory is to just tier things. We set out a block configuration for the 1 dot portion of the factory, and for each successive tier of quality we just reduce the number of rows we use for that process. We just build smaller and smaller variants of the same factory within the same basic factory footprint. This is a good setup mainly because it is easy. Okay, there are a lot of conveyor belts running up the middle of these factories. We are dealing with 5 times more stuff than we were used to, and each one is on its own conveyor belt, and that can be a complex system to build. But the philosophy is easy to see. The main issue I have with this kind of setup is that the size of the factory you build for the 4 and 5 dot portions are inevitably going to be bigger than we need. By the nature of this set progression, of each bank of machines having less and less rows, we are eventually going to reach a point where a single row of factory is more factory units than we can justify, unless we start leaving gaps. I don't like gaps. This leads me to this kind of setup, which is the same basic idea, just with 4 and 5 dot buried in the middle of 3 dot and addressed perpendicularly. The conveyor belts for 3 dots are here. The conveyor belts for 4 and 5 dots are here and here. The outputs are all sushi anyway. All of the outputs are being sent to sorting widgets for sorting, so it matters not whether the outputs match. All good. Maybe 4 dot could do with a few more units. I don't know. Nothing is perfect. I gotta keep telling myself that. These are good options for large factory processes, when we need a lot of factory units and when we need a different number of units for different processes, or different shape units, or units with pipes. But when we need a lot of small factory processes, like in, say, a mall, then building a unique individual factory for each process is going to get tiresome. We need a general approach to doing factory. Welcome to my mall on Vulcanus. The idea of this layout is that we deal with each successive quality on its own for multiple processes, all using the same bus of a single quality of ingredients. We then collect up the various sushi qualities of each process, and then keep the stuff we want and scrap the stuff we don't. This is a good setup because the bus of each successive quality is exactly the same. We build the bus we want for 1 dot, and then we just copy it 4 times, maybe just using slightly fewer machines as we go. But again, there is a limit to how few machines we can use without creating gaps. This is the sort of things that I only care about. If there are multiple stages in a process, like within an assembly machine or an inserter or the like, then we take the sushi that runs from the first process in that chain and use one of the sushi filters from earlier, one of these things, to run that sushi through the next process in the chain and scrap everything that is left. Or if it's a speed module, take all of the ones that are left after sending them to assembly machine 3 and send them to speed module 2, or vice versa. These are all the same basic systems that we have been talking about this entire video, just at a smaller scale. 9. The bus. I have tried 2 ways of arranging things in the bus. 1, arrange by quality. 2, arrange by ingredient. So if we look at this part of the bus on Vulcanus, we can see steel plate, copper plate, and iron gears grouped by their quality. Legendary things together, 4-dot things together, etc. If we take a look at green circuit boards, however, we have all the qualities of this single item grouped together. Legendary greens, 4-dot greens, all in the same bundle. Now, looking back at them all, with these buses of individual qualities, we've got 1-dot quality here, 2-dot, 3-dot, 4-dot and 5-dot. The places in the bus where I've arranged those belts by quality, all of the splitters need to address the same belts in the same place, because this is arranged by quality as well. So all of these belts at some point need to be diverted down. But because they're all in the same orientation, we've grouped them by quality in this bus, and so by grouping them by quality in this bus as well, all of these splitters are on top of each other. If we approach it in the opposite way, whereby these items are grouped by quality, but the items in the bus aren't, then we just address each one of these items one at a time, and they don't get in each other's way. This is a difficult one. It's not difficult. The thing is this is actually a relatively simple point. I wouldn't ordinarily have included it in a video of this type, but it is genuinely so transformative. This is a mess, and this is kind of sequential and elegant. It's so transformative that I felt like I had to include it. Anyway, next point. 10. The shuffles. The full Monty approach that I'm describing in this video is not the only way to achieve quality. There are 2 other methods that we can utilize. I just don't like either of them. The first is what has become to be known as the low density structure shuffle. When we make low density structure in a foundry, there is only a single solid ingredient, plastic. Iron and copper are processed as molten, i.e. a liquid, i.e. a thing that has no quality. So if we feed a foundry with legendary plastic, molten iron and molten copper, then we will get legendary low density structure. The quality of the produced low density structure is determined solely by the quality of the plastic we feed it. If we were to place max quality productivity modules in the foundry, research low density structure productivity to the max, and then recycle that low density structure, then we would get all of the plastic back that we put in. Because of the productivity multipliers that are available to us in space age, this loop can be engineered to never lose plastic. It's not the only loop. The more I look, the more loops I find for this kind of infinite stuff. Space age is a very different game from old Factorio. This is the low density structure shuffle. Plastic gets shuffled into low density structure and then scrapped out of it, and nothing is lost along the way. The seed plastic is always maintained, so the process can run forever. And every time we scrap a legendary piece of low density structure, we gain legendary steel and legendary copper. For free, basically. We are essentially taking the regular, nothing special, molten iron and copper, inserting a legendary piece of plastic to the process almost as some kind of catalyst, and extracting legendary copper and steel at the end. We lose nothing but molten stuff, but we gain a torrent of legendary. Easy, huh? What's not to love? Well, for a start, this is only legendary copper and steel. No iron and no circuit boards. We might have more legendary steel and copper than we know what to do with, but if we don't have a corresponding amount of the other ingredients, then there isn't really much we can do with it. We have 5 parallel factories, don't forget. It's all well and good concentrating on the legendary, but we need a smattering of other quality items to make the whole factory worthwhile. And we can't just build a legendary factory if all we have is legendary steel and copper. We would need legendary everything. And the proportions of that legendary everything need to be somewhere in the reasonable. They need to be comparable. It's no good having 1,000 legendary steel and 1,000 legendary copper if we only have 1 legendary green circuit board. And this is before we get into the methods that would be required to produce those maximum productivity modules in the first place. Biter eggs, anybody? As a method for generating legendary copper and steel, there is no other that can compare with the low density structure shuffle. It is incredibly effective. And if legendary copper and steel is all you are looking for, then this is the chap for the job. but in a well-proportioned factory, you will end up with a lot more legendary steel and copper than you need, more than your factory can process and more than your factory can balance. It is there if you want it, but it ain't a slam dunk. The second shuffle method that we can use to generate legendary things is the asteroid casino. Much as I hate the term casino, it's gambling, I suppose, it's probably all the same. These are the asteroid reprocessing recipes. We take an asteroid, we put it in a crasher, and it has a probability of spitting out either the same asteroid or a different one. If we put quality modules in the crusher, then there is a chance that the asteroid will upgrade in quality. If we run this loop an infinite number of times, then eventually every asteroid that we process will turn legendary. And when we process that legendary asteroid, it will output legendary stuff: iron, copper, carbon, sulfur, ice, and calcite. Short of legendary stone, this is basically a list of all the things that we would need to build a legendary-only factory. If we built a big enough asteroid processing ship in space and fed it with enough asteroids, then it would only ever spit legendary material at us. There would be no need for the full Monty, and this whole video would be irrelevant. I mean, you might be guessing why I don't like it. The reason this video isn't entirely irrelevant is that at some point, don't know when, it is going to happen, but as far as I'm aware, that's all we've been told. This asteroid casino is going to be patched out of the game. At some nebulous point in the future, it won't be possible to reprocess asteroids with quality modules, and the asteroid casino will be gone. So while it is possible now, it won't be possible forever. So while I could have included it in the video, I haven't. 11. Back to the spectrum. I showed you this spectrum at the beginning of this video, and I said that gambling was on one side and that this full Monty idea was on the other. So what exactly exists in the middle then? The full Monty is 5 parallel factories running in tandem, each addressing a single quality process. They obviously need to interact in a number of ways, the ways in which I have tried to describe in this video, but ultimately it is 5 different factories for 5 different qualities. We don't necessarily need to do 5 different qualities. The first stages in the chain, the iron, the steel, the copper, etc., we can decide at some predetermined point in the factory process to just scrap everything that isn't a particular quality in pursuit of higher qualities. Upcycle. We are making iron plate in a foundry. We take all 1-dot iron plate and we immediately turn them into boxes and scrap them until a better quality is achieved. If we do that for all main factory ingredients, then we only need to build a 2-dot to 5-dot factory. We don't need to build the 1-dot part. And let me tell you from experience that the 1-dot portion of the factory is the most significant part. If we can cut this part out, then we can probably halve the area footprint of our factory at least. And 2, if all we care about are legendary things, then probability wise, the 1-dot portion of our factory is going to be the least productive of any of the qualities. It will produce the least amount of legendary things. However, it will still produce legendary things. For a set amount of ingredients into the factory, we will get more legendary things if we do the full Monty than if we do this 2-dot to 5-dot variant. It just won't be much more. We will get slightly less yield. We move down the yield spectrum just a little bit. We could do the same with 2-dot stuff. Make a whole lot of 2-dot iron boxes which we scrap in search of 3-dot iron and just build a 3-dot to 5-dot factory and move down the yield spectrum a bit more. If we keep going, we just end up with a factory which is scrapping everything that isn't legendary and just building a 5-dot factory, which is basically gambling. This is the spectrum of yield. It is a spectrum of work. How much work do we want to put into achieving quality? Because the more work we put in, the more qualities we choose to retain and process through the factory in their entirety, the better the yield we will achieve. We also have to build the factory correctly and scrap and sort things in the right way and build the correct amount of production and make the ultimate quality modules. Look, nobody said quality was going to be easy. I'm pretty sure the exact term I've been using this whole video was devious. But the more easy you make it for yourself, the less you can expect from your factory in return. 12. Conclusions. I have built, at time of video, 3 different quality factories, and I'm very close to completing a 4th. I am still learning. I do not intend this video to be a complete breakdown of quality, merely my own interpretation of it. A version which has basically worked twice now. The first quality factory was an experiment, a failed experiment, but you know, we all learn. Having written this video and discussed the subject with another Factorio player who was also pursuing quality, I have become aware of further optimizations that I could make. Methods that would reduce the scrap chaos I am experiencing from the infinite loop. Potential different ways of approaching the same quality problem. The fundamentals were the same though. We get more yield the more qualities we process. The more yield we want, the more work we need to do. And all of the potential different ways that I could optimize the systems I have built in the 2 factories where I've gotten quality to work successfully at scale would all require more work. My full Monty factory is not at the top of the yield spectrum. There exists factories with greater yields than I have been able to achieve. There is still work for me to do. 13. Fulgora. Now, this was meant to be the end of the video. I finished this script weeks ago, and I've wanted to start recording for a while now, but there's something been bothering me, and that's the sushi. I've set out a theory for a sushi quality base in this video. I've provided some possible mechanisms for how this could work, the differences it would have from the full Monty I am trying to describe, but I hadn't actually built it. The examples I have provided have all been for small, self-enclosed issues. They have not been for an entire base. Well, I have spent the last few weeks building that base. I was going to try and add it to the script, but all things considered, it is a video in its own right. So if you think I haven't told the full story here, that there is a part missing, you would be right, and it is coming. Alright then, I hope you enjoyed the video. These videos, they're getting longer, these kind of tutorial guide type things. In that old Factorio, in 20 minutes, half hour, you could cover most topics quite adequately. It's new space age, everything's just so much bigger. You know, quality is just one small aspect. There's several of these things I need to make in the near future. Anyway, moving on. I just want to say thank you to all of my Patreons. This is something I've set up very recently. Obviously, because there's not many of you, but of the ones that are here, I am incredibly thankful. I think you're all awesome. If you want to support the channel, you know, potentially make this an indefinite thing where I can make content indefinitely, forever, then pop on over to Patreon, Patreon/AnotherBigfoot, and join the club. Yeah. So thank you to everyone. I also want to say a very special thank you to R1, who was the friend of mine who's helped me through this script and through the maths of this whole endeavour. Very helpful, very patient. I can be quite a blunt person when someone casually explains to you that you are wrong, how and why you are wrong. You know. Anyway, thank you for watching. I will see you in the next video. I need a freaking biscuit.